Hi all. Unit 5 Introduction to ASIC. So, in this unit, we are going to see the design flow, ASIC design flow. So, types of ASICs we know that semi custom and full custom ASIC, okay, and field programmable gate arrays. That is types of ASICs will come, and next to that, the design flow, where we can start the for fabrication of integrated circuit. So we must go step by step. Okay, so design flow, which says that so the step by step procedure to design a integrated circuit, okay, using ASIC methodology. So in this first one is design entry. So what it will do in this design entry, whatever are the concepts which we want to fabricate, so that we must be prepared in a documentation part. So design entry deals with the specification of the requirement. After that, logic synthesis. Once the documentation is over, and you need to convert that design concepts into a program. So that is done by Verilog and VHDL hardware description languages. After that, it go for a simulation. Once our code is getting ready, whether this will work properly or not, we must check. So for that, we have a simulation process. After that simulation is done, then going for logic synthesis. That logic synthesis tells about your digital hardware. So whatever the programs you have written in Verilog or VHDL, that must be converted into a digital logics in terms of slices, flip-flops and registers and logic gates, multiplexer. So what kind of logic you have written in Verilog, that corresponding digital hardware must be present in the netlist after the synthesis process. Then once netlist is created, so we may have an idea about what are all the digital hardwares available. Okay, then it should be partitioned. That system partitioning. So where we have to keep small components, and where we have to keep the bigger components, so to making as a comfortable compatible. Okay, so that is going with system partitioning. So once this gets over, then we need to check with the pre-layout simulation. Okay, so once pre-layout simulation it's done, and we can go for a floor planning, or otherwise we need to check again design entry, logic synthesis and system partitioning. These steps are there before going for floor planning. Once pre-layout simulation is done, then we can move on to the floor planning. Till that we are in a logic design. Okay, then next we are going for a physical design. And floor planning, it will assign each and every component inside a chip. Okay, that is floor planning. And placements which gives the shortest placements which gives the accurate places where we need to place the component and nearby, and how much gap will be there, that things present in the placements. After that, routing, the connections between the blocks happen in the routing. Once routing is done, and you can go for a circuit extraction, and you check with the simulation, post layout simulation. This is called post layout simulation. Even if it is getting good result, then you can go for design rule check, or otherwise again we need to check with floor planning and placement and routing. Then finally check with the rules and getting ready to the fabrication process. Okay, this should be the iteration. Okay, if we are not meeting that requirement what you have written in specification, again we have to do all those process in once again. Okay, so before going for fabrications, we can do n times the simulation process. Okay, once we tap out, so we cannot do anything. That is simply explained in this text. Design entry logic design is created using hardware description language, and logic synthesis it's converted your netlist, and system partitioning logically divide the entire system into small ASIC size blocks. And before going to the actual physical layout, whether it's tools checking the circuit for proper working or not for the logically, that is pre-layout simulation. And floor planning, physical design is arrange all the blocks of the circuit on the chip. Location of the logic cells in a placement which tells about the location of the logic cells in the block or set. Routing, once placement is done, that can create the connections between among the cells. And extraction determine the resistance and capacitance of the interconnections previously made. So since they decide the delay of the signal, all delays are calculated in this stage. And post layout simulation, once physical design is complete, the circuit is again tested for working. Okay, take consideration for the simulation process. Final step is to verify the layout, and we'll go for a fabrication process. So such ASIC chips are used in sensors and transducers, automotive and avionic systems, microcontroller processor, radar and satellite. Wherever we need a specific automation for automation, we need an integrated circuit that is manufactured by ASIC technology. Thank you.